This is a continuation of the previous video reactions test 3 part 2.1. And so I left off right here. I'm going to be continuing right here on, I'm not sure what page this is. However, we'll be talking about cyclic anhydride. So this is opening a cyclic anhydride once formed, and this will give us an ester and as a carboxylic acid. Then we have the reactions of anhydrides, and they show you how to form an anhydride like I described in the previous video. And as you would expect, right? We have this reaction with H2O. We have a reaction with alcohols. We have a reaction with amines, and so all these go down the reaction, the ranking of reactivity. So back to our graph, right? Back to our ordering. So first we have the acid chloride. This is the most reactive. And then we go downwards in reactivity, going down with acid chloride or acid bromide. Then we have the anhydride. Following that is the ester, then the alcohol, then the amide. And then on their own, we have the anhydride, which is aldehyde, sorry, which is more reactive than the ketone. And these are on their own because these function differently than these groups. These groups have a leaving groups, we can kind of say that they have leaving groups. And this gives them a level of reactivity that is different than what a ketone or aldehyde has. And so these are not really comparable to all of these. But in terms of reactivity, obviously a acid chloride is far more reactive than aldehyde. And I believe all these are more reactive than the aldehyde or ketone, I believe. So these are all we can understand the reactivity by looking at what the leaving group is. So for each one, we know how this works. So we have some nucleophile that comes, and it's going to come and attack the carbonyl carbon. This is going to go up, come back down to reform the carbonyl and kick off the leaving group. Right? So, a sequence of steps, this would be like step 1, step 2, right? This step 1 and 2 happen at the same time. Then you have step 3, which comes down, and step 4, which happen at the same time. So it does this system of steps, and it kicks off the leaving group and reforms the carbonyl with the addition of the nucleophile that's present here. And so essentially, you can understand the reactivity of all of these by looking at the leaving group or the group that forms after this reaction happens. So for the first one, we would get Cl minus, right, which is a halogen, and halogens are extremely stable and preferable actually to have this negative charge, right? So they handle it very well. They have very high electronegativity, and they prefer to have this -1 charge. The next one is this O, right, anhydride. It forms this group. Once this is the group that leaves. It's going to be an O minus, and it has resonance with a carbonyl. So I have O minus, so relatively electronegative atom that resonates to another electronegative atom. And so we have resonance and we have atom stabilization. Then this one we have just no resonance, but we just have stability as O minus. So that's fairly stable. And then we have OH minus that forms over here, and then we have N minus. So you can understand the reactivity of these in this way. All right, so going back to the reactions, right, so that makes sense that I can use H2O to form a carboxylic acid, I can use an alcohol to form an ester, and I can use amines to form a amide. And all these are less reactive than the anhydride, and that's how it will always work. This next one is the reaction and synthesis of esters. So they show, the Fischer esterification, and they show the trans esterification to give us, well, this is actually not trans esterification. This is an acid chloride, and this is a carboxylic acid. So we have those two ways to form an ester. This way might be, depending on whatever is most convenient for you, and synthesis is the one you'll use. Then you have a lot of these reactions, which, all of them you should understand. besides this one where you have to memorize. So you guys should understand H2O and H plus. That's easy, right? And that's just OH attachment, or just OH minus. That gives us the carboxylate. Transesterification, which is the process of switching out the OR group on the ester. So using a new R group that is an alcohol, an H plus will an excess amount, very important, an excess amount to give us this switched out group. So nothing has changed besides the thing that is there. Then using amines, right, of either the 0-degree primary or secondary, we can form an amide. And then this reaction right here, you need to memorize, will turn an ester into an aldehyde. You have the reduction that you should know already. And then you have the Grignard and organolithium, which allow you to form ketone. And then if another series of reaction occurs, right, because it's still present, and we've formed a, still something that is electrophilic, right, the carbonyl, it'll attack again and give us the dual substituted alcohol. Here we have the cyclic formation of esters of an ester. So we have an alcohol and a carboxylic acid on the same molecule. Presence of H plus, this will form preferably either a 5 or 6 membered ring. Those have the best stability. So not 7, usually not 8, not 4. Usually 5 or 6 are what's preferable. Okay. This is just the formation of cyclic anhydrides, which we've shown before. This is forming a anhydride, so this is 2 carboxylic acids in high heat. This is breaking a cyclic anhydride, which you've seen already. I don't know if amide reactions are on your exam, but I know. Well, I think they are. So that's not that hard really. So if you have a amide, right? This is reactions of amides. So you have the LiAlH4, H2, H2O plus. You need to know that it does not form an alcohol. It just completely reduces this carbon, and it gets rid of the carbonyl. Then you need to know that an amide in the presence of POCl3 or SOCl2 or P2O5 gives us a nitrile. Okay, this carbon and this nitrogen become the nitrile, and you need to know that it can only work in the presence of a primary amide. So you have a nitrogen group that has only one kind of R group on it. All right, so this one only works with these to give you a nitrile. So in reaction 3 right here, we have Br2NaOH H2O. This will completely remove the carbonyl carbon and have a direct attachment to the nitrogen group. And so this one also only, I think this one also only works with primary, but I'm not exactly sure. But I think that's what the other TA that I work with said. But you might want to check your notes with Bean for this. But I think it only works for primary. Then moving on, so these are fairly simple. The only one that's really new are reaction 3 and reaction 4. This one is a reaction of nitriles. So nitrile being reduced gives you the fully reduced nitrile, CH2, NH2. You've seen this, the what's it called? The hydration of nitriles. And then it seems like they're repeating a little bit. Okay. But anyways, so you have the same stuff on this side, and they also show you H2, P2 can also work. All right. I'm not gonna show you guys this just yet in this video. This will be the next video, and that pretty much covers the majority of the reactions for this exam. The next stuff is like the chapter, I think 21 and 22 material that will be on your exam, and really it's a little bit complicated, but it's honestly not so bad once you get used to it. But yeah, best of luck learning this material, and really, really get comfortable with this stuff. And honestly, it's not that bad. A lot of the stuff is the same and just a different environment. And if you understand how the mechanism works for one of them, you basically understand it for all of them. All that is required is some understanding about, the reactivity order and what is more reactive than what. Besides that, it's fairly easy. All right, best of luck, guys, and yeah, start studying as soon as possible.